Avogadro's law states that volume and moles are directly proportional, so long as the pressure and temperature remain constant. This means that if I have a container of gas where the temperature and pressure are constant, and I add more moles, then the volume will increase. In a simulation, we can see the balls as representing the amount of moles of the gas, and if we hold temperature and pressure constant, and I add more of those moles, we can see that the volume increases as well. And this is how Avogadro derived his gas law, stating that the initial amount of moles divided by the initial volume is equal to the final amount of moles divided by the final volume. So, for example, if a 2-liter container of 2.3 grams of oxygen gas increased in volume to 4 liters, the temperature and pressure did not change. What is the mass of oxygen that was added to the container? So our first step is always to list out our givens, which is that the initial mass is 2.3 grams, the initial volume is 2 liters, the final volume is 4 liters, and we're trying to solve for the final mass. So we have one mass, which means that we can always find the amount of moles by dividing by the molar mass using the equation moles is equal to mass divided by molar mass, which in this case is 2.3 divided by 2 times 16, and we're multiplying oxygen's molar mass by 2 because it is O2, oxygen is diatomic. And the amount of moles we should get in this scenario is 0.071875 moles. Now we should pay attention to the fact that it says temperature and pressure did not change, which means that we can use Avogadro's gas law to solve for the final amount of moles, which we can do it by rearranging the equation to N2 is equal to the final volume times the initial moles divided by the initial volume, and we should get 0.14375 moles. And with this, we can use the other equation, m is equal to moles times molar mass, to find the mass, the final mass of oxygen in the container. And we should still remember to multiply oxygen's molar mass by 2 because it's still diatomic. And we should get 4.6 grams, but this is not our final answer because we need to subtract the original mass since it's asking how much oxygen was added to the container. And we should get 2.3, which if we round to sig figs, is 2 grams of oxygen was added to the container.